would definitely be so embedded in the language is probably generics. Version 3 added link, but with link, a lot of features had to be put into the language that you can use that you don't also have to be using link at the same time, like type inference. If you like using var, you don't have to specify the type on the left-hand side. And there's a whole bunch of other things that got added to support link in version 3. Version 4, you can see that then the number of features are going down a little bit. You know, conversely, from generics, dynamic is probably one of the features that I could do without easily. I don't know if I've ever used that feature, and I just generally try to stay away from it if possible. It's not that it has no use or that it isn't, you know, powerful, but yeah, I try to just stay away from that one. Version 5, again, not many features. Had a big one though, asynchronous methods, being able to program in an asynchronous fashion using async, await, and also the task type is something that now is pretty prevalent in our language since this point. You notice that the number of features is going down a little bit, and in part, I wouldn't say this is the biggest reason why, but in part, the C# compiler was always intended to be an API and also available for developers. So you may have heard of this thing called Roslyn. Roslyn is the compiler for both C# and Visual Basic. It is an open source compiler, which was quite an interesting announcement back in 2014, because that was, again, one of the big indicators that the open source view that Microsoft had seemingly held for many years was rapidly changing. So C# is compiled with C# via Roslyn. So that's the compiler. It's open source. So if you go to the commit page, I should say also that if you look at the notes section in all of my slides, I do have links to what I'm showing on the slides as well. So if you download them, you'll see where this graphic is coming from. This is basically showing all the effort that's been done in the compiler. And the people that are listed here, they work at Microsoft, they work on teams related to .NET and C#, so it makes sense that they would be at the top of the list. But if you did scroll down on this list, you'll start to see people that don't work at Microsoft that have made contributions to the language, to the runtime, and so on. If that's something that interests you, you can go to the link that this page is coming from. You'll see that label community. And those are ones that have already been curated to say somebody from outside of Microsoft's walls. This is probably a good one to pick up because it doesn't have a lot of work associated with it, and it's not easy, but someone who's not used to this can probably pick one of these up and try to actually do the work there and contribute to .NET, which I think is an amazingly cool thing. What's interesting is from this point on, version 6, this is when Roslyn became the compiler for C#. All the work was done in the open. You start to see a rapid increase in the speed of versions, like how, not just in how they perform, like .NET in general, but how the language is evolving. It's becoming faster and faster from this point on. So you see this initial set of features, and this was all done out in the open the first time for version 6. Version 7 played with this idea of point releases. So you didn't just have a set of features coming for 7, but there was a 7.1 and a 7.2 and a 7.3. Okay, so this was also try to say, let's not do these big bang releases every year and a half or 2 years. Let's see if we can be a little bit more nimble. And now what you're seeing with C# is with version 8 and beyond is a little bit more of a predictable cadence. We're now getting into where C# is going to be released every year. Version 8 is also where you see a bifurcation. So some of the features that show up in version 8 either cannot be used at all in .NET Framework, or you have to do some gyrations to make it happen. So this is where .NET Framework 4.8 is really become the endpoint for the Windows-only version of .NET. This wall of text that you see here, you can see the thing in bold. That's what matters, because C# does not, I'm sorry, that .NET Framework 4.8 does not support .NET Standard 2.0. So C# 8 has limited support there. And this just continues on from this point on. So if you want to be on the train where all the new stuff is happening, .NET Core and now just .NET, that is the train to be on. You see this with version 9 that was released last year, and now with version 10, which these are the features I'm going to go through today. These were released last November, and this is going to continue on. .NET 7 will be November of 2022, and .NET 8 will be November of 2023. Okay, that's the roadmap that they have published a couple of years ago. Past that, we don't really know yet what's going to happen, but that's at least the roadmap that we've seen. So I'm going to go into Visual Studio and demonstrate a bunch of these features for you. Again, if you have any questions or anything, feel free to put them into the chat in Teams, and if you see me looking over here, it's because I have the window open over here, so I'll be looking at it occasionally. If I'm forgetting it or I'm not seeing it, just come off of mute and say, "Hey, Jason, hold up, I got a question," and I'll be happy to just stop and try to answer it as best as I can. Okay, so I have here just a console app that what I'm going to be doing is uncommenting and commenting out, excuse me, methods and then calling them, and that will illustrate what the feature is. This is going to go at somewhat of a rapid pace because not only do I want to get through these features, I do want to show some things that are coming for potentially C# next, or what will probably be called C# 11. So I do want to leave a little bit of time there, especially since one of those features has really raised a stink with a small yet vocal crowd in C#, and we'll get to that later. But some of these I'll go into a little bit more detail than others. Some of them are actually very minor, small features, and in some ways they're actually they're fixing something that's been there for quite a while. And at this point, it's just, oh, we just did this little thing, so now this works. So some of these, I may just show you the code and talk very quickly about what it is. Okay, so we're just going to keep going through one feature to another. You'll notice also with each one of these methods that I have a couple links associated with them, so you can go click on those and find out more information about those features later on. Okay, so the first one is this one. These first two actually got a fair amount of press when the C# team was talking about 10 features. This one's called Global Using Namespaces. Okay, so if you look at this code, you'll see that I'm doing a couple of write lines, I'm getting some constants, and then I'm printing those out as well. So if I run this code, it should be no surprise that what's going to happen is I'm going to see a bunch of stuff showing up on the command line. Okay, but what may be a little weird or different is, for one thing, I'm just calling writeLine. I'm actually not doing like console.out or just console.writeLine. None of that exists here. You'll also see that I have the usage of math, but I don't have, using system, or I don't have that namespace up at the top either. So what's actually going on here? By the way, if this also looks weird for a program file for you, in C# 9, I believe they added what they call top-level statements. So you don't need to have you don't need to specifically create a program class with a main method. That is all synthesized for you now. So it's a little bit less code. And that's what this global namespace and file scope namespaces, that's what these features are trying to do. They don't make your code any faster per se, but it takes away a little bit of code that you normally have to write. And it's just a little bit less noise. Okay, so if I go look in the actual project file, one thing, no, not here, I actually have them in what's called a directory build props file. If you don't know what a directory build props file is, highly recommend looking at it, because you can put a bunch of project settings in this file at your solution level, and they'll be applied to everything within each project. Of course, a project can override them by specifying a different value. So I find this to be very helpful to saying, you know what, I want to make sure, well, in this case, I actually have lang version of preview because I'm going to show you a preview feature later on. But I can state that. I can say I want nullable enabled. I want to treat warnings as errors and so on. I want to make sure that, for example, here's this global feature coming into play, is I want to make sure that the system collections immutable namespace is being used in every project within the solution. So I can specify this in a props file or a csproj file with the setting and saying I want to include it. Okay. You can also, if I go back here, you can also say implicit usings enable. And if I say that, then a set of usings, and this is based on whatever your SDK is for your project. For example, if I come back here, I'm just using the Microsoft Net SDK. You can use Microsoft Net SDK Web. There's other ones as well. And if you look up the documentation, there's a list to say, if you want to have this included, implicit usings, based on your SDK, a whole bunch of expected things like using system collections generic, and so on, are automatically going to come in, and you don't have to specify those anymore in your files. So in all these files that you have in a project where you're probably typing in using system or using system threading and so on, you don't have to do that anymore with this feature. So it's a little bit less noise at the top. You can also do something like this, where you can put it into your file and say global using and then the namespace. But this also works for type aliases. So you'll notice here that I'm saying global using static system console. So I no longer need to even use console globally in any of my files in this project. That's why this write line just works. This is also why math works, because system is automatically included. Okay. If we go into this constants factory, get values, you'll notice that we're using an immutable dictionary. But as I showed in the props file, we're including that using here with system collections immutable. So we don't need that at the top of the file either. So there's a couple of different ways where you can enable and light up this global usings feature. You can do it in a props file or a CSproj file, or you can use it for type aliases, or you can define these within just the project itself. At the end of the day, the whole point is to reduce that noise at the top of your file. Now, you don't want to necessarily globally include every using namespace, because you could run into a case where a type has the same name across 2 or more namespaces, and now you'll have a collision and you're going to have to somehow try to resolve that. So you only want to, if you're going to have like a file like this that I was using for the alias, you don't have to call it using CS, by the way. You can call it whatever you want. The global keyword is what matters. Okay. You can put them all here as well, but the thing is, you may not want to put in all of them here because of that issue. So you want to be a little judicious and careful about what usings you want to make global. I've actually created a tool called, and you can get this from NuGet, it's a .NET tool called Using Usings. And what you do is you install this tool, and then you just run that tool on a directory. And what it will do is look at all the CS files within that directory and give you statistics to say, which using statement are you using the most within all your files? And then you can have a little bit more of a statistical analysis to say which ones do we think might be beneficial to say we can have this as a global and not have these as using statements anymore in our files. Okay, so that is global usings. Let's move on to file scope namespaces. So what is this? So in this case, we have a customer that we're going to create, and we're going to print out the customer. And as you can imagine, we're probably going to get a customer that shows us some information. The thing to notice here, though, is that when I say print out the type of the customer's full name, is that we get this fairly long namespace here. And this is not atypical of .NET code, where you're putting into a namespace that is descriptive and helps define more about that type. As a side note, a type's name is actually the namespace plus the name. So it's just a convenience so that you don't have to say my type's name is this big long thing. Then you can have kind of a grouping as well. But that's technically the type's full name, is the namespace plus the name. But let's go see how this customer is actually defined. So if I go in here, you'll notice at the top that we don't have a block scope for the namespace here. All we have is this semicolon at the end, and now we've lost the block scope. So there have been a couple of features that have been coming into C# where, for example, if you've ever wanted to say, I'm using a disposable object. So you'll say using var service equals blah, blah, blah. You'll put a block there, you have some code, and at the end of that block, C# emits a try finally statement for you. In the finally block, it calls dispose on that object. But what they allow you to do is say, if that using block goes all the way down to the bottom of the enclosing block, you don't need that block anymore. You can just say using that statement and you can move on from there. This is very similar to that, where virtually all the files, I know this myself as well, virtually all the files I've ever created in C#, I have, maybe some usings, which I don't need that much anymore. I have a namespace, and then I have a type. So all this does is, for example, if I want to say convert to block scoped namespaces, I can do that and go back to the old way, or I can use this and say convert to file scope namespace. Now, unfortunately, this isn't giving me the option to say do it across the whole solution, but I can at least get the refactoring to say, make all of my namespaces this, this top level feature. I've pretty much converted any of the code that I'm on to using this. And again, because it's a little bit less noise, it's not going to make my code any faster, but it's a little bit less noise, and you get your code moved over to the left a little bit more. So, it's a little bit more compact, and you don't have to do this. You don't have to use global usings either. Nobody's forcing you to have to do this. But I personally found these two features to, clean up a little clutter. And that's one thing that the C# team is trying to do with some things in the language, is if we're trying to teach new people about the language, if you use a language like Python, and I show the hello world, I think in Python it's either just print or it's print ln or something like that. It's just one method that I can put a string in and say run, and I get that to happen. In C#, I have to have a program class, and I have to have a main method, and I have to have a using, and I have to say console write line. And for somebody that's new to programming, that's actually a lot of noise to start out with, and it doesn't make it as clean of an introduction into the language. Now, this isn't why these features were added, just to make it easier for people to understand C#, but it does remove some noise. It does remove some things that you don't have to understand as many concepts either as when you're coming into the language. Okay, so from a convenience standpoint, I kind of like them. There's actually a couple of things in C#10, one on string interpolation that we'll talk about improvements in performance in a moment. But these are just, cleaning up what you're seeing in code itself. Record structs in C#9, there were these things called records that were added. So, you could basically declare on one line of code a class that had properties, had a constructor, had equatable implemented for you, was immutable by default. You could clone it. You could use these things called withers. So you could create a new instance of an object from an object and say customer with, the name equal to this, and then the new instance would have that new name, but all the other values were there. So it provided a lot of functionality for you out of the box, but it was only implemented as a class. So a record is, in C#9 world, a class underneath the scenes. There's no difference between the two. It's just generating a lot of code for you. So that's fine. But what happens if I wanted to actually have it be a struct? Because, in certain cases, a struct may be better for performance. I may want to use it for that purpose. So you couldn't do that in C#9, but now in C#10 you can. If I run this code, we get our struct customer by the name. You're going to see how this is defined in a moment, but it still works just like a typical record would. If I actually go into the definition of the record, you'll notice here, this is the C#9 way to do it. So it's a public record, record customer, and then this generates a whole bunch of stuff for us. You have flexibility in terms of how you actually define a record. I'm not going to get into those details here, but what I do want to show here is that I can actually now declare the record as being a struct. If I want to be explicit, I can say class here, but you don't have to do that because the default is a class. So that's up to you if you want to do that. You can also, as I show in the comment here, you can make the struct read-only. So if you want to read-only struct, you can do that as well. Okay. So, small thing, but it gives you a little bit more flexibility in design with records if you want them to be structs or not. Sealed record to string, I'm going to skip over that one because it's actually just a very small case. The parameterless struct constructor, this is interesting in the sense that if I go, I'm not going to run this, but I'll go into the points definition here. Go into that. You'll notice that I have a struct that has a parameterless structure. And then I toString it, and I've got my property set this way. This may not seem like that big of a deal. Okay, but what's interesting is that I went back and tried to like set the lang version to previous versions of C#, and this wasn't allowed. You couldn't do this. So now in C# 10, you can actually create a struct with a parameterless constructor. Now this may not seem like that big of a deal, and to be fair, it's not. You know, in a lot of cases, this may not be that big of a deal. But if you do want to start creating structs with a parameterless constructor, I would highly encourage you to take a look at this document itself, parameterless struct constructors, because they're, for the most part, it's going to work the way you expect, but there are some corner cases that you do want to be aware of. So if you read that document, you can go through it and see like, and there is a fair amount of them. Don't let that scare you, because for most things, it's just going to work the way you expect it to. But it's kind of the way how structs are value types, how things get initialized, how properties get set up and stuff like that. So just take a look at that document if you want to start creating structs with parameterless struct constructors. Okay. All right. Mixing declarations and variables. This is just if you've been using what are called tuples. I don't say tuples, I say tuples. So if you've used those before, like this, where I have a record customer, records automatically support deconstruction out of the box. Deconstruction is, do I have a method on my class that has the word deconstruct, returns void, and all of its parameters are out? You can then deconstruct those values into a tuple. So it's a nice little convenience syntax. The thing is that you weren't able to reuse the variables that were within a struct like you can now. So now you don't have to have like a different var, different name here if I want to do it again. I can actually reuse the name variable, and that works just fine. Another minor but nice convenience that was added is with anonymous types. Anonymous types were added in C# 3. So as you see here, I can create a customer that doesn't actually have any type name to it. If I hover over customer, you may be able to see, if you squint hard enough, you'll see like a tick A. And so this is some weird anonymous name for this type, because it still needs to have a type. You just don't know what it is, nor should you care about what this type is. Okay. But what you couldn't do before with anonymous types is what you can do now, is this with statement. I alluded to this just before with records, that I can actually create a new instance of a record based off of an old one. But in the new one, I can say this property is actually going to be this value. Okay, that's what they call withers. You can do this now with anonymous types. So if I declare this anonymous type to have an ID and a name, I can now create another one that's going to have the same ID, but a different name. And actually, I'll just run this just to show this. We should see two there, where the first one's Jason, the second one's Jane, but the IDs are the same. Okay. So that is anonymous types. Excuse me, I'm gonna take a little drink here. Extended property patterns. So since C# 7, there's been a lot of work in the language to do a lot more with patterns. Pattern matching, the switch statement is been expanded to do a whole bunch of things so that you can basically say, if the value is this, then I want to return that. If the value is this, I want to return that. And so these old style switch expressions that have been around since the days of C, you can now actually do them in a much more succinct way. And so ever since C# 7, there's been more and more work to add more and more patterns. In fact, there's going to be a feature that's being proposed for a future version of C# that's also an extension of patterns. We'll get to that later on. The one small thing, though, that they did in C# 10 is this pattern where they're saying, I want to say, well, if the thing I have is a record customer and it's the length of the name here is greater than or equal to 5. I want to write this out. This is a little klutzy to do it this way. And so what they did is they just said, well, you can extend this pattern match to basically do it all within one. So you don't have to have these, blocks within blocks to do it. Again, this is a very small thing, but it's a nice little addition to how you can do the pattern matching. And I'm kind of curious. So yeah, you can actually see now, I don't think this was in the last time or the previous time I've done this presentation, but sometimes Visual Studio, if you look at the name, you'll see this little white dot smudge thing underneath it. That means that there's a potential refactoring that you want to consider. And so what they've done now is saying, well, yeah, what you can do is just simplify the property pattern to this. And if there's other cases with this in your solution, you'll notice that I could actually tab or just arrow over to solution and say, apply this across my entire solution. There's a lot of refactorings and analyzers and code fixes now in Visual Studio that can make refactoring much, much easier. And just to do a really quick plug, if you've played with 2022, which is what I have here, you may have started to notice that there's this thing called Intellicode that's trying to predict what you're coding or give you ways, like if I start editing a file in a similar fashion, if I do it again, it will start to offer a way to say, by the way, I've noticed you've done that. This pattern exists in your code like another 8 times. Do you want me just to do this the other 8 times? And when I need to update something in code, that is a huge time saver. I was just writing, if I'm pointing over here, this is my Workday's computer for the day job. And I was updating some code, actually put some tests in a certain place. And I was astounded at how good Intellicode is predicting what I needed to put in for my next test. This isn't a talk on Intellicode, but if you've seen that happen in Visual Studio, it's not perfect, but man, it's been a time saver in certain cases. So, all right, better Lambdas. This is actually a kind of a big one just because it makes things more succinct. And if you've heard of minimal APIs, you've already run into this. So let's say I want to have some weird function that's going to take my customer and return a big integer. And what this function does, we don't really care. It's just a combination of a couple of values. Okay, so it's not so much what the function does. It's the fact that if I want to declare a function using either a func or an action, I have to say new func, blah, 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 and then what this does. Okay. What you can do now in C#10 is just declare it like a function. You'll notice here what I'm saying is I have a function that's going to take one parameter, this record customer. The implementation is the same as what you see up in here, but if I hover over customer processor 2, you'll notice that C# has inferred this to be a func of record customer big integer. So it's a little bit less syntax than what you've needed before. Now, this may not seem like that big of a deal with this, but when I've done things like this is actually pretty helpful because no longer do I have to declare all this sugar, this syntactic stuff to specify what the type is. I can now just do it this way. And so that's a little bit less code. It's a little bit nicer to read. And in my opinion, it is. And it's going to do the exact same thing. Both of these end up being a func of 3 ints. Okay. Same exact thing. And this is, I'm not going to show minimal APIs here, but this is exactly what minimal APIs is relying upon so that you can declare like a map get and say, this is my function and this is the body and move on. And I personally really, really like that. I find that to be very enabling, very easy to set up APIs if I need them on a project. So with minimal APIs and this better Lambdas feature, they work very much in concert to make it easy for you to declare those. I should also note that in C#10 that this also works not just with funcs and actions. For example, I could have a function here that takes a ref string A, and it also has an attribute here. Okay. If you know actions and funcs, they can't be used to describe this function. You can't have a ref here and you can't have an attribute here. Okay. But if I hover over this, you're going to see anonymous delegate. Okay. But it would work if I call this invocation is just fine. Okay. I can also have a function with a whole bunch of parameters. Now, I'm not encouraging this. If you see code in an application that has 19 arguments, you have bigger problems than having this being supported with a feature in C#. Okay, so the fact is, though, that C# understands this. And if I hover over this, you'll see it says anonymous delegate. I'm going to use a tool called ILSpy, which is a free tool that's a decompiler that you can use to just point at any assembly and have it decompile it for you. And the reason I'm going to use this is because I want to hover over a couple things here. You'll see that in this assembly, we have this compiler-generated delegate that has a lot of parameters there, okay? And we also have this one created that has a ref of T1 here. And if I go down to, where is this? Better Lambdas, it may be a little bit hard to see in this decompiled code, but you'll see here, this is where we're using a delegate that has ref and also has the attribute here, and this one has all those parameters. So C# can also go the extra yard to do some cases that actions and funcs can't handle. Okay. And if you're wondering why you couldn't do this before, it's because C# couldn't tell the difference between, in this case, is this a func of a record customer big integer, or is this an expression of a func of a record customer big integer? Because they were declared exactly the same way. And so what they've done now is basically say, in the vast majority of cases, what you want is a func or an action. You want a delegate, you don't want an expression. If you want an expression, you're explicit now to say, I want to actually use an expression, and then that works the way it always has. Okay. Constant interpolated strings. This is just now that if you have a string that you want to use interpolation, you can now do this. So you don't have to concatenate them all together like this way as a const. You can do this so long as these values can be resolved at compile time, because these are going into a constant. So these can't be things that are going to be computed later on. But you can use an interpolated string syntax for constants in certain cases now. Caller argument expression. I like this one. This is fun. This one is basically saying, I want to see at a call site of a method what the expression was to get that value. So what does that mean? Well, I'm going to run this one here. This one is saying, for example, if I come here, I want to print out a Boolean result. Okay. And in this Boolean result here, I've got this expression to say whether it's true or false. And I'm also just going to say true. Now, if I actually look at the local method print Boolean result, I'm passing in the bool here. I have a caller member name. This is basically saying who's calling me. And this has been around since C#5, I believe. But now we have this caller argument expression where I say the name of the parameter, and then I pass this, I have this caller argument expression parameter. What the compiler is going to do is say, what was the expression that you used to pass in this value as a string? And then I'm going to put that in here. So then we have this interpolated string here that's putting all this together. When I run this, watch what happens. I get true from main. This is the actual main method that when you're using a top level statement, that's the caller. It looks weird, but that's actually the caller. But notice in this first case, it pulled all that code and put it in as a hard-coded string. So you could pass that in. In the second case, well, what the expression is the literal true value. And so that's what gets passed in here as well. So for debugging, this can be hugely helpful because I no longer have to say, well, at a certain point in code, what actually happened? What was being done to get this value? I can use caller argument expression to just have that hard coded in to the assembly. So it just works and it just happens. Now, of course, you have to be a little careful with this because you don't want to necessarily have a big expression there that you're passing in, because that's going to be a string that's embedded into your assembly. And so that's going to, I won't say bloat it, but that's going to add a little bit more there. But certain cases, this can be very, very helpful. Argument null exception, throw if null. You'll notice that it's got like the argument and then also the param name. Argument null exception, throw if null actually also uses caller argument expression. So you can do this all in one line and get an argument null exception with the right name of the parameter because it's using this as well. So that's pretty cool. Okay. So I'm here. Interpolated string improvements. I think, yeah, that's going to be the last one I look at before we do some C#11 things. The async method builder override is a really corner case, complicated feature that the vast majority of people are not going to use. But if you're interested in what this is, check out the details on it later. The interpolated string improvements. So if you notice back up here, I have interpolated string. Okay. And let's make sure that I'm actually compiling that in because I want to make sure the assembly has it. Okay. You've probably used interpolated strings a lot in your C# code. The thing is, underneath the scenes, the way it's been implemented wasn't always ideal. The performance wasn't always the best. Not to say it was bad. I want to be very clear on that, but it was known that it could probably be a little bit better. Okay. So what is being done now, this isn't a feature that I'm going to be able to do in the language itself. It's what's being done underneath the compiler, and what shows up in the output, that's what matters. So if I go back to ILSpy here, and I go to caller argument expression, okay, and I go to print Boolean results, because that's where the interpolated string is done, you'll notice that now we have this thing, default interpolated string handler. And if you look at this, this is the same thing as the string up here, result from caller member name doing this, except all those holes are filled in with a pen formatter. And then we have a pen literal. So what the compiler is doing with your interpolated string is actually using this handler and wiring up all the appends and then doing a toString and clear. This handler is also a ref struct. So this can only be used in cases that I think your method can't be async. The interpolated string obviously has to just be within a method body because ref structs can't leave the scope of the method. But for a lot of cases, this is exactly what you want. And this string handler has much better performance than what was there before with how C# did the interpolated string. So this is nothing that you have to do any differently in your code. You just may see somewhat of an improvement, especially when you're using interpolated strings with how that's actually created. You know, there's lots of things that the .NET team does from a performance standpoint. If you ever look up Stephen Taub and performance improvement in .NET Core 2.1 and 3 and 5 and now 6, there will probably be one for 7. There's a ton of performance improvements that go into every version. And a lot of those are just things you don't need to do in your code any differently. They just light up and happen. And this is one of those cases. So just by moving to C#10, your interpolated strings will probably in all likelihood be a little bit faster. Okay. All right. So that is C#10 really, really fast. Okay. So again, if you have any questions, I'll keep looking. Come off of mute, ask me if, you know, what is this actually doing? Okay. So that's C#10. Again, that's the whole list there of things that were put into C#10. What about the future? Where are we going to go from here? As I mentioned before, C# is an open source language now. Wasn't that way to start, but it is now. The compiler is open source. Pretty much everything in .NET is open source these days. Much different approach. And because of that, that roadmap, that path is fairly clear. Now, as you start going farther down the road, you know, you can't necessarily see what's in that little valley, and then the road goes off to the right, and you're too far in the future, and really even the C# team doesn't know what's going to happen at that point. But you can see at least to that first hill, to the next spot, and at least get a decent feel for where the next features are, you know, what they're going to be, and maybe even the one after that. Okay. So right now, if you go to the page that's listed in the notes section here, there is a version next. And they always say next because they don't want to be explicit to say it's going to be called C#11 in this case, though that's probably what it's going to be. This looks like a lot, and it is. And I want to be really clear here to say that This is not a committed list. Okay, I want to be very clear here and to say this is not a committed list. What you see here may not actually show up in the next version. So if you come back 6 months later and go, but Jason, I saw this and you talked about it and it didn't actually show up in C#11. We were writing all this code to use this, and why was it removed? This is in flux right now, not committed. Okay, I would actually start from the top left, read to the right, go to the next line, read to the right. From a betting perspective, that the ones that's at the top left, those are probably going to be in the language. And as you start going down, the odds start to go down a little bit. That's the way I would take it. But again, that doesn't mean like something like checked operators is not going to come into C#11 or the next version. I want to show you just a couple of things that's on the docket for next features. One of them I can show in Visual Studio right now. And then the other one I'm going to use SharpLab.io. If you've never seen that, you'll see what that is in just a moment. So this thing called, let me comment this one out. This thing called static abstract members and interfaces. If you want to use this, you have to have your Lang version to preview. That's one of the things you need to do. You also need to enable preview features in your sys.proj file. This runtime experimental thing is not required, but if you want to experiment with this thing called generic math, you need to include this library, and you want to make sure that it is, unless you're actually targeting a .NET 7 preview, you want to make sure it's the latest 6.0.2 version in NuGet. Long story short, something got busted from when they first released this preview to where this is right now. And the way to fix this is just make sure that you're using the latest preview version of this package, okay? So what this actually does is it gives you the ability to start declaring things and interfaces that are static, which you might go, well, why would I do that? Part of the reason is operators are static. You've never been able to handle operators in a generic fashion because you can't express them as something that's available to be in a base class to say all subclasses must implement this, okay? Well, with static abstract members, that's no longer the case. So if I have a local function here that I say I want to add two things where as long as they implement this thing called iNumber, then I can say left plus right. You've never been able to do this before in a generic way. So not only can I say I want to add two integers together, I want to add two doubles together. And that generically works just fine, okay? So if I run this, let's just say run. Oh, no, that's not going to work. I need to uncomment this. If I, oh, what did I just do? There we go. That's better. So if I run this, you'll see that we get these two values here. I'll show what the customer thing is in a moment. That just works fine because if I go to the number interface and I go to the addition operators, you'll see that I have the static abstract tResult operator plus. Now, there's a lot of generic noise here, so I don't want to dive into too much of this. But the end result is I have the ability to define something in interface that is static and abstract. And this means that the implementation class has to provide an operator of plus, okay? So this allows you to be a lot more expressive with generics and numeric types, but you can also use it for things like factory patterns. For example, if I go into create here, I have a customer that has a private constructor, but has a public factory method, create. But the cool thing about this is I'm able to enforce this by an interface that is generic to say, I want you to be able to create something of whatever the self type is, okay? So since I'm able to create it here, I can have a consistent pattern to how I create things. Think of try parse. That's another one that we just do by convention. That could be enforced by this kind of pattern with static abstract members. This is also potentially really helpful if I wanted to do something like static abstract async task of T-self. Thank you, Intellicode. If you just saw what that did, that's what Intellicode does. It predicted what I wanted to do. Now, of course, I'd have to implement this in my customer class. But the thing to notice here, actually, I wouldn't need to say async here. I could take that off. But the thing to notice here is if I've ever needed to call an asynchronous method in a constructor, I basically need to have this asynchronous factory pattern in place. I can enforce this with a static abstract member, have that on my type, and it just will work. Okay, so this is a very powerful feature from a type perspective. There are a couple of other things to look at as well that are coming down the pipe. Looking at my time here, I got time. Okay, cool. So this is something called SharpLab.io. If you've never used this before, it's a kind of an interesting site that allows you to just type in code here. You can see what it looks like as decompiled. You can actually also run it. You can see the syntax tree of it if you want. And some of these things take a little bit of time to run, but you can see this is the actual compiler syntax tree for this code, okay? You can also see the IL. But what you can also do is up in this list is you can say, hey, I want to use certain branches that have been created by the C# team that already have some of these things in place. For example, raw string literals, okay? So I might want to have something in here where I say var x is equal to this is a string. Now, the fun part of SharpLab.io is that sometimes it gets a little confused. Like this may not entirely work. I hope it does. Sometimes refreshing the browser helps as well. But the point of this feature is you'll notice I have this triple double quote. And so what this is saying is what is within those triple double quotes, that is literally what I want to produce. Yeah. So this is really nice if I want to create JSON or XML, or I create a lot of source generators and I want to have C# code in my string, but because of formatting and escaping and all this other stuff, it can be kind of a pain. In this case, all I have to use is this triple double quote, and then that becomes what's called a raw string literal. Let's refresh the browser and see if that actually helps this code. Hope it does. Yeah, SharpLab is being unhelpful. Make sure I can actually get there. Did I crash it? That would suck. Okay, my browser's still working, so that's good. Did it finally come through? I don't think it did. What's the warning here? Variables assigned but never used. Oh, okay, so we'll just say int m, and then we'll say return x.length. There we go. Okay, now we got SharpLab.io. It is a little twitchy at times, but you'll notice that we actually have that raw string literal turned into something like this. Okay, so that's kind of a nice feature. Another one is, let's see if I can find generic attributes. So let's just get rid of this class here. Actually, we'll get rid of this here. Okay, and we'll make that a void. What I can do now is I can say public sealed class my attribute, which derives from attribute. Whoever create attributes, this is very familiar. What I can do now is actually have a generic within the attribute. Okay, and hopefully this compiles. You'll see that this actually does work. Okay, this is actually a preview feature in Visual Studio 2022 that you can play with as well. So there are these generic attributes. The last one I want to show is one that's gotten a lot of press, and some people really, 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 really don't like this. So let's say I have a method here that takes data, okay, and what I want to do is return the length. Excuse me. Pretty straightforward. Okay. Oh my God. Oh geez. There we go. That should work, and it does. Okay. The thing is, I'm assuming this is not null, and there are nullable reference types added in C#8. Where I could say if I think it could be null, then I put this in here, but then I have to make a check that data is not null. Blah blah blah. If I want it to be null, though, I also should say if data is null, or what I could do in argument null exception. Come on. Oh, if null, and data here, and that would work. Okay, but I want to put that check in there. This proposal is basically saying that's the same thing. So hopefully the compilation will come through on the right. And what you'll see here now is if you squint hard enough, my method M is using this throw if null on data, blah, blah, blah. This is all compiler generated. But what this does is it's actually doing a null check for you on this method. I personally think this is a cool thing. I like it. Some people have been very, very vocal that they don't like this at all. Like a lot of things, you don't have to use it. But this also leads to how can I get involved with the community, because I want to know when these features are being talked about. Quite frankly, this parameter null checking feature has been talked about for at least 3 years, as far as I know, on the C# team. A lot of iterations. Do we use attributes? Do we do it a different way? You know, this is actually proposed for C# 10 and they dropped it. So there is a lot of talk on these things. And so what I want to leave you with is, if you're interested in the design of C#, the repository is out there in GitHub. There's a whole bunch of information that you can find on C#, specifically not just with what features are there, but where the language may be going. The C# team has language design meetings like once or twice a week on average. These are not open to the public, but all the notes are published within basically a day of the meeting occurring. So you can go to the repository. They have the markdown files of all the things they've been talking about in the language. You can go to this page. Well, there's other things that they're talking about that they might want to add in the language in the future. Type classes is a very big thing. That's kind of where static abstract members and interfaces have come from. If you want to develop a language feature, you can also do it. There's a defined process and what you need to follow to make this happen, but you can do it. And that fire has been lit by people in the community that they have done that themselves. They've actually implemented some features that are in C# that you use, and the Microsoft team works with them, would work with you, but they're the ones that are actually driving that process. So that's all I have for this presentation. Hopefully you've seen not only what, where C# has come from, what's in the latest version, C# 10, but what may be coming down the road in the future, and where you can find out more information about that direction and evolution of the future of C#. So that's all I've got. I think I just hit my time. And, if you have any questions, maybe I'll just watch a little bit, but otherwise, jason.r.bock@outlook.com or Twitter @jasonbock.
Okay, Jason, thanks so much. Stop the recording and feel free to hang out if anybody has any more questions.
Okay. Yeah, I'll watch her come. I do have a